Hey guys, this lesson is on adding and subtracting fractions. First, we're going to look at adding and subtracting fractions that have the same denominator. So when we have the same denominator, we're just going to add or subtract the numerators, and we're going to keep the denominator the same. So if we look at 8/12 minus 1/12, we know that 12 is our denominator, and it's the same for both fractions. So since it's the same, we're going to keep it. Now with the numerators, we're going to subtract them because this is a subtraction problem. So our numerator will be 8 minus 1. So our final answer will be 7/12. Now I want you to try the second one, 9/10 plus 4/10 on your own and see what you get. Okay, let's go over it. Again, our denominators are both 10, so we're going to keep it. So we're just going to slide that right on over. And in the numerator, we're going to add 9 plus 4. 9 plus 4 is 13. So our final answer is 13 out of 10. And you'll notice in this fraction that the numerator, or the top number, is bigger than the denominator, or the bottom number. That means that this fraction is an improper fraction. And we'll learn more about those a little bit later on. Now, when we're adding and subtracting fractions with different denominators, we have to make the denominators the same before we can add or subtract. We can use the butterfly method, the multiples method, or the opposite denominator method to do this, but it's important to remember that before you can add or subtract, the denominators have to be the same. When we use the butterfly method, it's best to use this method when the denominators are small because we end up having to multiply the denominators by each other. So we're going to draw the wings, the antenna, and the body. And then we're going to multiply diagonally inside the wings. So 3 times 2 is 6. 5 times 1 is 5. I'm going to bring that subtraction sign up. And then we're also going to multiply inside the body. So 5 times 3 is 15. That number inside the body becomes our denominator. And we're going to add or subtract the top numbers to get our numerator. So 6 minus 5 is 1. And our denominator will be 15. So our answer here will be 1/15. The next method we're going to look at is the opposite denominator method. Now it's important that you understand that no matter which one of these methods we use, really we're just creating a common denominator and then adding or subtracting the fractions. So we're really doing the same thing no matter what method we use, we're just doing it in different ways. In the opposite denominator method, we multiply the numerator and denominator of one fraction by the denominator of the other fraction. This is also best to use when the denominators are small. Once we've created that common denominator, we can add or subtract. So in this example, when I look at 1/2, I'm going to look at the denominator of the other fraction and multiply the numerator and the denominator of 1/2 by that number. So 1/2 becomes 5/10. And what that's done is created an equivalent fraction. I know that 5/10 is equal to 1/2. So I haven't changed the value, I've just changed the numbers. When I look at 1/5, I'm going to multiply by the denominator of 1/2, which is 2. And that gives me 2/10, which is an equivalent fraction for 1/5. So now I've created equivalent fractions that have the same denominator so that I can easily add or subtract. I know from looking at the problems before with like denominators that I just keep the denominator the same and I add or subtract the numbers on top. Well, 5 minus 2 equals 3. So my answer for this problem would be 3/10. The next method we're going to look at is the multiples method. This is a method of finding a common denominator that's easiest to use when the denominators are larger and you don't want to multiply them together. For example, in this one, if I had to multiply 6 and 8, that would give me a denominator of 48, which is a really large number to work with. So it's going to be easier to use the multiples method and find a different common denominator using the least common multiple. What we're going to do is we're going to list the multiples of each denominator and find the smallest one that they have in common. So if I look at the multiples of 6, I would have 6, 12, 18, 24, 30, 36. If I list the multiples of 8, I'd have 8, 16, 24, 32, 40, 48, and I could keep going if I needed to. Now, if I look at these numbers, I see that I have a match in the number 24. Well, that's going to be an easier number to work with than the number 48. So I want to take each of my fractions, 3/6 and 3/8, and create equivalent fractions with a denominator of 24. Well, I know that to get from 6 to 24 by multiplying or dividing, I would have to multiply by 4, and I have to do the same thing to the numerator that I do to the denominator. To get from 8 to 24, I have to multiply by 3. So now the fractions that I'm working with are 12 over 24 and 9 over 24. Now I have a like or same denominator, so I keep the denominator and add the numerators. And I know that 12 plus 9 is 21. So the answer to this problem is 21 over 24. Now we're going to do some practice problems. Just remember that you can always rewind the video if you need to watch the examples again. So try these two problems on your own and then we'll go over them. Okay, in both of these problems, we have like denominators. So my denominator will stay the same and I will add or subtract in the numerator. So for that first problem, the answer should have been 5/4. In the second problem, I'm going to also keep my denominator the same. 3 minus 1 is 2. The denominator is 6. So my answer to that one should have been 2/6. Now we're going to look at some problems that have different denominators. You can choose which method that you would like to use. So try both of these problems, and then we'll go over them. Okay, for this first problem with denominators of 3 and 6, those are small denominators. You could probably just use the butterfly. Now, if you used a different method than the butterfly, you might get a different answer. As long as a different answer that you get is an equivalent fraction, then that's fine, it doesn't matter. So I'm going to multiply in the wings. And in the body. I'm going to add the top numbers. So 6 plus 6 equals 12. So my answer is 12 over 18, or any other fraction that is equivalent to 12 over 18. So for example, 24 over 36 would work. 6 over 9 would also work. In the next one, the numbers 5 and 12 are a little bit larger. I'm going to use the multiples method. Now, like I said before, you could use any method you want for any of these problems, as long as you get an answer that's an equivalent fraction. So I'm going to list the multiples. until I get something that they have in common. So in this problem, the least common multiple is 60, which is the same thing you would have gotten if you used the butterfly or the opposite denominator method. So I need to take 4/5 and change it into a fraction that has a denominator of 60, and 5/12 and change it into a fraction that has a denominator of 60. I need to create those equivalent fractions. To get from 5 to 60, I multiply by 12, and 4 times 12 is 48. So my equivalent fraction will be 48 over 60. To get from 12 to 60, I multiply by 5. So my new fraction will be 25 over 60. When I add them together, I keep the denominator the same and add the top numbers. My final answer is 73 over 60. Now I want you to try these last two problems on your own, and then we will go over them. Looking at the first problem, 10 over 12 minus 2 over 3, or 10/12 minus 2/3, you really could use any of the methods you wanted for this one. I'm going to use the multiples method because 12 times 3 is 36, and that's kind of a big number. So I'm going to list out the multiples of 12 and the multiples of 3 and see if I can find one smaller than 36 that they share. So for 12, I've got 12, 24, 36, 48, 60. For 3, I've got 3, 6, 9, 12, 15, 18, and I've already found one that they share that's smaller than 36. So I'm going to use the number 12. So I need to change 10/12 to a fraction that has a denominator of 12. Well, I really don't have to do anything to it. I would just multiply by 1, right? So 10/12 can stay the same. For 2/3, I would need to multiply by 4. So now my problem is 10/12 minus 8/12. So my final answer would be 2/12. Now, if you did the butterfly method or the opposite denominator method, you should have gotten 6 over 36. That last problem, 4/5 minus 1/2, has really small denominators. So I'm going to use the butterfly. So I'm going to multiply inside the wings. And I'm going to multiply in the body. So I know that 10 will be my denominator, and my numerator will be 8 minus 5. So my answer will be 3/10. Now I could have also used the opposite denominator method. So for 4/5, I would multiply by 2. And for 1/2, I would multiply by 5. So that becomes 8/10 minus 5/10. And since we keep our denominator the same and subtract the numerators, I get the same exact answer.